Imagine looking up at the night sky, far beyond the familiar constellations and the gentle glow of the moon. Envision a celestial wanderer, a giant space rock silently hurtling through the vast expanse of space, drawing ever closer to our home planet. This isn't just any space rock. Picture one as big as the iconic Leaning Tower of Pisa, a colossal monument dwarfing everything around it. Its sheer size is awe-inspiring, a testament to the immense scale of the cosmos. Now imagine this behemoth flying by Earth. A close encounter with such a massive object would undoubtedly be a sight to behold, a cosmic ballet of epic proportions. This week, Asteroid 2025 OW, a name that might not inspire immediate awe, but its presence certainly does, is making headlines. It's a massive ancient traveler, a relic from the early days of our solar system, carrying secrets from a time long before life even began on Earth. This week marks its closest approach to our planet, a celestial rendezvous that has scientists and space enthusiasts alike buzzing with anticipation. But don't worry, scientists are excited, not worried. There's no need to sound the alarms or brace for impact. They get to study this cosmic visitor up close, using powerful telescopes and advanced instruments to unravel its mysteries. This is a golden opportunity to expand our knowledge of the universe. By analyzing its composition and structure, we can learn about the building blocks of planets, gaining insights into how our own world came to be. Most asteroids live in a belt between Mars and Jupiter, a crowded region teeming with rocky debris left over from the solar system's formation. But some, like 2025 OW, are wanderers, their orbits taking them on journeys that swing closer to Earth, offering us a unique glimpse into the cosmos. NASA and other space agencies have been diligently tracking its path for years, using sophisticated radar technology and complex calculations to predict its trajectory. And their data confirm it will safely pass by, a comfortable distance away from our planet, posing no threat to life on Earth. So, instead of fear, we get a front-row seat to a rare astronomical event, a chance to witness the grandeur of the universe and marvel at the celestial mechanics that govern it. This is all thanks to the science that keeps us informed and safe, the tireless efforts of astronomers and researchers who dedicate their lives to understanding the cosmos. It's a reminder of the wonders happening above us every day, the countless celestial events unfolding in the vast expanse of space, often unnoticed but always captivating. The Leaning Tower of Pisa stands about 185 feet tall. That's the size of Asteroid 2025 OW. Imagine a building that high, or a jumbo jet, tumbling through space for billions of years. It's not a planet killer, but it's big enough to be tracked and studied. For comparison, it's like a 15-story building floating past Earth. These comparisons help us grasp the scale of this cosmic visitor. Scientists care about size because it helps them predict what would happen if an asteroid ever came too close. Tiny meteoroids burn up as shooting stars, giant ones can cause global catastrophes. 2025 OW is in the middle, big enough to notice but not a threat. It's a tangible connection to the vastness of our universe. Close in space is very different from close on Earth. Asteroid 2025 OW will pass by at about 393,000 miles away, over 1.5 times the distance to the Moon. That's still incredibly far, so there's no danger. In astronomical terms, anything within a few million miles is considered close. Scientists can predict these paths with amazing precision, so we know exactly where the asteroid will be. This is a safe, distant flyby, an opportunity for science, not a cause for worry. Our cosmic neighborhood is busy, but we have the tools to understand and stay safe. Enjoy the show from a very safe distance. Asteroids pass by Earth all the time, silently gliding through the vast expanse of space. These celestial wanderers, remnants from the early solar system, are constantly crisscrossing our planet's orbital path. Most are small, insignificant pebbles, posing no threat and often burning up harmlessly in our atmosphere as shooting stars. But every now and then, a larger asteroid catches our attention, reminding us of the dynamic and sometimes unpredictable nature of our cosmic neighborhood. But 2025 OW is special. It's not just another space rock. It's a relatively large object making a close approach to Earth, making it a point of interest for scientists and space enthusiasts alike. Its size and proximity set it apart from the countless other asteroids that routinely pass by our planet. This week, it's the biggest asteroid coming this close, a celestial heavyweight in comparison to its smaller brethren. Astronomers have been tracking its trajectory, carefully calculating its path and assessing any potential risk, however minimal. The data collected provides valuable insights into the composition and behavior of these space rocks. About the size of the Leaning Tower of Pisa. Imagine that iconic structure not standing firmly on the ground but hurtling through space. This gives you a sense of the scale we're talking about. It's a substantial object large enough to cause significant impact should it ever collide with our planet, although thankfully that's not predicted to happen this time. Most other space rocks are much smaller, mere fragments of asteroids or comets, often no larger than pebbles or grains of sand. These tiny particles are so numerous that they constantly bombard our atmosphere, creating the mesmerizing spectacle of meteor showers, like cars or even smaller. Think of the difference in scale, a car versus a skyscraper. That's the kind of size disparity we see between 2025 OW and the more common smaller asteroids, or buses, which are still dwarfed in comparison to the sheer size of 2025 OW. These everyday objects help us grasp the magnitude of this celestial visitor, and go unnoticed. They are simply too small to be detected by our telescopes and monitoring systems. They pose virtually no threat and are often only discovered after they've already passed by. 2025 OW stands out because it's both big and relatively close, making it a more prominent object in the night sky and a more interesting subject for scientific investigation, making it a prime target for scientific study. Astronomers around the world are using telescopes and radar to observe 2025 OW, gathering data on its size, shape, composition, and trajectory. This information helps us better understand the asteroid population in our solar system and assess any potential future risks. It's like spotting a giant ship sailing near the shore, a majestic vessel that commands attention and sparks curiosity, while smaller boats pass by in the distance, barely registering on the horizon. The size difference is striking, highlighting the significance of the larger object. Events like this get people excited about space, igniting a sense of wonder and inspiring us to learn more about the universe we inhabit, and remind us to look up and wonder at the vastness and beauty of the cosmos, filled with countless stars, planets, and asteroids. It's a chance to contemplate our place in the universe and appreciate the intricate dance of celestial objects. 2025 OW is the headliner of this week's cosmic concert. It's the star attraction, drawing our attention to the wonders of space and the ongoing efforts to monitor and understand the objects that share our solar system. It's a perfect chance to learn about our solar system, its formation, and the diverse range of objects that populate it, from planets and moons to asteroids and comets, and the science that keeps us safe. The dedicated efforts of astronomers and scientists who work tirelessly to track potentially hazardous asteroids and develop strategies to protect our planet from any future impacts. The universe is a vast and awe-inspiring place, filled with countless stars, galaxies, and celestial bodies. Among these are asteroids, rocky remnants from the early solar system, silently orbiting the sun. But how do scientists spot a rock, sometimes kilometers across, in the seemingly infinite vastness of space? It's a cosmic needle-in-a-haystack problem of epic proportions. The answer lies in a combination of human ingenuity, international teamwork, and cutting-edge technology. It requires a dedicated global effort, bringing together the brightest minds and most advanced instruments to safeguard our planet. At the forefront of this planetary defense is NASA's Planetary Defense Coordination Office, working in close collaboration with global partners across the world. This office acts as the central hub for detecting, tracking, and characterizing potentially hazardous asteroids. These organizations use powerful telescopes, both ground-based observatories on Earth and sophisticated space telescopes in orbit, to constantly monitor the skies. Each type of telescope offers unique advantages in the search for these celestial wanderers. Night after night, these telescopes meticulously scan the skies, acting as sentinels against potential cosmic threats. They tirelessly collect data, searching for anything that might pose a risk to our home planet. The key is to look for moving dots of light, asteroids, objects that stand out from the fixed background of distant stars. These faint trails of light are the telltale signs of an asteroid traversing the solar system. The challenge lies in distinguishing these moving objects against the incredibly dense and complex background of stars, galaxies, and other celestial phenomena. It requires sophisticated algorithms and careful analysis to filter out the noise and identify genuine asteroids. Once an asteroid is found and its presence confirmed, the real work begins. Astronomers worldwide, connected through a global network of observatories, immediately begin to track its path across the sky. This collaborative effort is crucial for gathering enough data to accurately determine the asteroid's orbit. In addition to tracking its movement, scientists also carefully measure its size and estimate its composition. This information is vital for assessing the potential impact risk. Using the fundamental principles of physics, including celestial mechanics and gravitational dynamics, scientists can then predict its orbit with remarkable precision, projecting its trajectory for decades, even centuries, into the future. This allows them to assess whether the asteroid poses any long-term threat to Earth. Take, for example, the asteroid designated 2025 OW. Thanks to extensive observations and sophisticated calculations, scientists know its path with incredible accuracy, far into the future. The good news is that, based on current data, it will safely miss Earth by a comfortable margin. Space-based telescopes like the Near-Earth Object Wide-Field Infrared Survey Explorer, or NEOWISE, play a crucial role in this effort. These specialized telescopes are equipped to detect infrared radiation, which allows them to spot even the darkest, most elusive asteroids that are difficult to see with visible light telescopes. This global network of observatories and space telescopes means that we're always watching, constantly vigilant, and always ready to identify and assess potential threats. Thanks to the dedication and expertise of these cosmic detectives, working tirelessly behind the scenes, we can rest a little easier knowing that our planet is being protected. The asteroid detection and tracking system works, and we're all safer for it. It's a testament to human collaboration, scientific innovation, and our commitment to safeguarding the future of our planet. Is 2025 OW going to hit Earth? Absolutely not. It will pass by at a safe distance, much farther than the Moon. Even if an asteroid this size hit, it wouldn't be an extinction event, just a regional disaster. NASA tracks these objects so we're always prepared, and missions like DART prove we can even nudge asteroids if needed. This is a story of science, discovery, and reassurance, not danger. Ever seen a shooting star? That's a tiny meteoroid burning up in our atmosphere. Our atmosphere protects us by vaporizing small space rocks. If something as big as 2025 OW entered, it would create a spectacular fireball, likely breaking up before reaching the ground. The Chelyabinsk event in 2013 was caused by a slightly smaller asteroid, which exploded in the air, shattering windows but mostly disintegrating. Airbursts like this are dramatic but rarely catastrophic. Our atmosphere is a powerful shield, and 2025 OW will stay far away. No fireworks this time. It's all just a fascinating what if. Some asteroids hide in the sun's glare, making them hard to spot from Earth. These Venus hiders can approach undetected, as happened with the Chelyabinsk asteroid. That event was a wake-up call for scientists to improve detection. NASA's upcoming NEO Surveyor and Infrared Space Telescope will scan for asteroids near the sun, finding those we can't see from the ground. This new technology will help us spot hidden threats and strengthen planetary defense. Science is always advancing, closing gaps in our cosmic safety net. By searching every corner of the sky, we're making Earth safer from surprises. Innovation keeps us one step ahead. As 2025 OW sails safely by, let's appreciate the science that keeps us safe. Global teams of astronomers and engineers work together to track, study, and prepare for cosmic visitors. The discovery and tracking of 2025 OW is a planetary defense success story. With new missions like NEO Surveyor and proven asteroid deflection technology, our future is even brighter. When you hear about asteroids, feel wonder, not worry. We're part of a dynamic solar system, and science is our shield. Thanks to our